Dear students, welcome to the Design of Machine Members class. So in the second unit, we have a topic called fracture. In the fracture, normally we know that fracture is separation of body into two pieces due to stress and temperatures below the melting point. The most structural materials fail by fracture. That is dividing of a material into two different pieces, and normally we call it a fracture, and we know all the structural materials normally fail by fracture only. So we have steps of the fracture. That is initially the crack will initiate, then the crack will propagate. Normally the crack will initiate at one particular time and it will propagate throughout the material in order to go make the body failure. So here we have a various types of fractures. In that the majority of two types of fractures are: the first one is the ductile fracture and the second one is the brittle fracture. The ductile fracture. The ductile fracture occurs with the plastic deformation. The brittle fractures has a little or very little or without any plastic deformation, we can say consider happens the brittle fracture, and it's a catastrophic one. So it happens very suddenly, very fastly. So ductile fracture versus brittle fracture. Most materials are not too cold. So extensive plastic deformation ahead of a crack. That is, before the crack or after the crack, it undergoes to the extensive plastic deformation before the failure. The crack is a stable one which resists further extension unless applied some external stress. Normally, if any crack was occurred in any mission element or structural element, it will be withhold that the crack will be in that place unless until some external force is applied, some stress is induced or stress increased, stress levels are increased, then only the crack will propagate. So during the crack propagation, so if it is very slow, depending on the plastic deformation, if crack will propagate, then we call this a ductile fracture. So normally for the cold materials or for the ceramic materials or for the ice materials, so here we can see chalk materials. All this is for this we can see very little plastic deformation. The crack was unstable and it will propagate rapidly without increasing the applied stress. Even the glass, you can see even if the small crack can able to disrupt enter the glass. So it's a brittle fracture. But in the during the ductile fracture, all the deformable materials, most of the metals, so unless until if it is not in too cold conditions, suppose in the later stage we do have DBDT, that is ductile to brittle transition operation. So every material there is a temperature cutoff. If you reduce the temperature more than that, then the material behavior will convert from ductile to the brittle. So and the fractures there will be brittle fractures. So this DBDT, before identification of this DBDT, most of the accidents in the deep sea areas or the sea areas, as well as in the aviation industry or in the marine industry, most of the accidents or incidents are occurred due to this DBDT. In the later stages, hearts of the scientists, they are identified that and there will be a certain temperature where the material behavior will convert from ductile to the brittle. When it is a brittle, it will fail even for a small destruction, even the small crack initiation or for the small plastic deformations, it will break into the different places. But in the ductile materials, first of all it will deform unless it can able to withhold. When it is unable to withhold, then the crack will be formed initially. Even if there is no much stresses or even after stress relief, the crack will be in the stable in such form. Further, if you apply the stress beyond this capability, then only the fracture will happen. So normally while we are designing, we always see at least ductile fracture materials we use. The ductile fracture was preferred in the most applications. Why? Because it will give warning before fracture. If you know that it is going to fail, then we can easily replace. Suppose if you don't know it is going to fail, but it is very difficult to replace. You can see the pictures of ductile and brittle fracture. So here it is for thin wires. It will be having very ductile materials. That is, it will elongate a large and it will form a cone shape. It will form a cone shape before failure. So it will give some warning before the failure. But here you can see moderate. Sorry, just a second. Yeah. So here this is a very ductile one. Ductile behavior, and here you can see a moderate ductile behavior, that is it is having a very little deformation, then the fracture will occur. And here this is a brittle, complete brittle one. Here we don't have any plastic deformation directly, part of it directly separates into two different pieces. Here we have brittle versus ductile fracture. Here you can see that with the increase of the stress, with the little strain only, the material reaches to its ultimate or breaking point, then the failure will occur. But so this is for brittle materials. Normal for ductile materials, what happens, we do have a lot of cushioning there, so it will pass through various stages before reaching to its break-even point or the ultimate point. So here before that we do have a lot of deformation points. So we do have a proportional limit, we do have upper limit, we do have lower limit. So after crossing all these limits only, it will go to the failure. We do have a toughness, that is the energy to break a unit volume of a material is normally known as a toughness. That is the approximate the unit area under stress strain curve, we normally consider it as a toughness. So suppose for polymers we do have a very small toughness, the pink color one you can see. For the metals we do have a large toughness, and for the ceramics also we do have small toughness. So brittle fracture we do have elastic energy. For ductile fracture we do have elastic plus plastic energy, both the things we do have. So up to some region it will be in the elastic region, and then it will undergo into the plastic region. So you can see the failure of a pipe for the ductile failure as well as a brittle failure. So ductile failure, it will give a crack and propagate, and it will open and it will stay there. For the brittle fracture it will be blasted out into the number of pieces. You can see the difference between ductile and brittle fracture. So initially we have in the ductile failure we have a necking, then we have a void creation, then we have a void growth and leakages, we have a shearing at surface, and the fracture will occur. So suppose if it comes to if you see the fractured surface, so these practicals since suppose it's for a composite material, there was taken these nucleus will act as cracks, and it will propagate the failure. So this is a cup cone fracture for a ductile material, and this is a brittle fracture. So finally, if come to let's see the summary of ductile versus brittle fracture. Here the stress, we have a brittle fracture and a ductile fracture. The stress is the fracture occurs at a stress below the yield strength of the material. The ductile fractures occur, the fractures occur at the stress above the yield strength of the material. And energy, the fracture is low energy process, here the fracture is a high energy process. And here the fracture is fast, here the fracture is low. And here the little or no plastic deformation, here is extensive plastic deformation. And surface planar, flat, featureless, here we have a very rough and fibrous surface we do get. So these are things about ductile and brittle fracture. Remaining things we will see in the next class. Thank you.